Okay, hold up. You know that moment when your phone buzzes low battery and you feel like the world is ending? Yeah, we've all been there. But imagine, just for a second, that the way we think about batteries is completely 100% wrong. Because guess what? It is. No, really. The batteries of the future might not even need lithium or any of that stuff we're mining and arguing over. Instead, they could work on, get this, quantum mechanics. Yeah, we're heading into seriously wild territory. So, buckle up, grab your coffee, and let's dive into the mind-blowing world of quantum batteries. So, first of all, what's the big headache about today's batteries? Let's talk basics. Batteries store energy chemically. You've got your lithium ions zipping back and forth between two sides, making your gadgets come to life. But here's where it gets annoying. They're slow to charge, degrade over time, and let's not even get started on the environmental prices we pay to build them. They're useful, sure, but they're not exactly efficient or sustainable in the long term. And this, my friends, is where quantum batteries just waltz in like, hey, we got this. Now you're wondering, quantum batteries? Seriously, what? Okay, let's unpack this. Remember that scene in every sci-fi movie with glowing power cores and humming energy balls that seem to charge in an instant? Yeah, quantum batteries are kinda, maybe, like that. They're a totally new concept that uses the principles of quantum mechanics. Specifically, something that is wildly different from what we're used to. Quantum entanglement and superposition. Oh, let's pause here because if you're new to quantum mechanics, you're possibly thinking, I have no idea what you just said. No big deal. Here it is in a nutshell. Quantum entanglement is this crazy phenomenon where particles become so deeply connected that the state of one immediately affects the other, even if they're miles apart. Like twin telepathy, but way cooler and, actually provable. And superposition? That's when a particle can exist in multiple states at once. Kind of like imagining me both drinking my coffee and spilling it on my shirt at the same time. Weird, right? But very quantum. So, how does this shenanigans of entanglement and superposition help us with batteries? Glad you asked. Here's the kicker. Normally, in a traditional battery, the energy transfer process basically happens one layer at a time. It's like waiting for every page to load in a digital book, one by one. Frustrating. But in a quantum battery, thanks to these quantum principles, energy doesn't just trickle. It jumps as if the whole book uploaded itself instantly. Essentially, it allows for super-fast, collective charging. It's like all pieces of the battery charge simultaneously. You charge one electron. It's like you've broadcast that energy to the entire system. And get this. There's no wear and tear, theoretically speaking. Our current batteries degrade because of what's happening on a chemical level. Ions moving back and forth, doing their thing, eventually wearing out. But a quantum battery? No moving ions. It's more like energy teleportation. Well, okay, not literally teleportation, but you get what I'm saying. There's no constant grinding away at materials inside the battery. This means not only instantaneous charging, but a potentially way longer lifespan. Can you imagine a car battery lasting decades without losing efficiency? That's the promise we're talking about. Alright, I know some of you are like, sounds great, Olympia, but is it real or are we just playing sci-fi here? Excellent question. Yeah, the science is very real, although we're in very early stages. A few teams of scientists, mostly in physics labs, have already done experiments on small-scale quantum batteries. They're using materials like quantum dots, which are basically teeny-tiny semiconducting particles, to create these energy storage systems. No, they're not powering Teslas or your phone yet, but the groundwork is being laid. Baby steps, right? Okay. But here's where the plot thickens. Quantum batteries don't just stop at being fast or durable. They also might reshape what we store energy for. Stick with me. Traditional energy storage systems demand big physical facilities, huge battery farms, the size of warehouses. But quantum tech? These could be light as air, or so compact that they fit anywhere. Plus, because of those spooky quantum properties, they could become an integral part of new computing systems, or even space exploration. Picture this: a spacecraft recharging itself mid-flight using built-in quantum storage systems. What kind of Star Trek future are we living in? And oh, there's more. One research study suggests that even sunlight photons could be directly and efficiently captured by quantum batteries without needing traditional solar panels. Can you even wrap your head around that? We're not just talking faster iPhones. We're talking a totally new way of tapping into energy all around us. Of course, this stuff is still a little dreamy, a lot of hypothetical models and mathematical proofs. But remember, so was electricity before it revolutionized every single part of human life. Now, let's balance things out for a second. It's not all sunshine and glowing quantum orbs here. There are plenty of hurdles to getting quantum batteries out of the lab and into your Tesla, or, let's face it, your Furbies, whatever you're charging. First, these systems are tiny right now, so scaling them to huge energy outputs, a massive engineering challenge. Then, you have the stability issues. Quantum systems are notoriously finicky. They're like trying to balance a spoon on the edge of a glass while a cat is watching. One wrong move, and poof, your delicate system collapses. And yeah, it's still really costly technology. You think lithium mining is expensive? Quantum tech requires outlandish resources at the moment. But folks, here's the thing. This feels exactly like the dawn of electricity's everyday use. Because 100 years ago, people probably thought incandescent light bulbs were a crazy, expensive party trick. And now, we have LED lights on our sneakers. When we crack the scaling problem, the quantum battery could basically redefine how we think about energy forever. And that's not an exaggeration. Oh, and before I forget, scientists are even wondering if quantum batteries could one day power quantum computers. You see, the control systems for quantum computers require an incredible amount of energy, and what better match than another quantum-based tech? It's a bit poetic, no? Like the whole universe working together. So where does this leave us? Well, you're probably still going to want to keep a charging cable handy for a while, but quantum batteries, if scientists are right, could make our energy systems faster, safer, more environmentally friendly, and durable. And that's not just important in a conveniently charge my phone kind of way. It's crucial to our entire planet. Better batteries mean better renewable energy storage and, ultimately, a greener planet. So tell me, what do you think? Is this just wild optimism, or are we staring at the next big leap in human technology? Seriously, I want to know what's keeping your gears turning. Drop your thoughts below. And hey, if you're as excited as I clearly am, make sure to subscribe. Because trust me, we're just scratching the surface of what's coming. And I don't know about you, but I need all the brain fuel for these revelations. So let's keep the conversation going and dive into the next scientific wonder together. See you next time.